In this next session, we are going to take a look at NX model-based definition and PMI on your parts. Jumping into a quick breakdown of our agenda here, we'll first take a look at what is model-based definition. Then we'll look at PMI capabilities, model-based definition capabilities, downstream uses for the PMI, and then we'll wrap up the session with a quick summary here. So we'll start out by talking about what is model-based definition. So looking at the diagram here, we have a couple of categories nested within each other here. So we have the PMI category nested inside the model-based definition, which is nested inside the model-based enterprise. So PMI is the product and manufacturing information. This is the application of the information such as notes, dimensions, maybe some feature control frames, bold circle center lines, etc. here, applying that 3D PMI to your physical geometry. So this non-geometric data is going to be applied to the 3D model, and it's going to convey information about your design of that product, and it's going to allow you to use this information downstream as well. Now we get into the model-based definition category here. This is the practice of producing a complete digital definition of your part within the 3D model, including the geometry, the PMI, and the metadata embedded inside of that model. Taking that into the higher level here, the model-based enterprise, this is the process of reusing the model-based definition by downstream consumers across the entire enterprise. Reuse of all this data and other operations inside the company. Taking a look at the 3D CAD NX PMI reuse here. First off, we'll talk about what is PMI. PMI is encompassed inside the model-based definition. Model-based definition is that complete digital definition of your product within the 3D environment or 3D model. PMI specifically is the product and manufacturing information which contributes to the model-based definition. It conveys information such as geometric dimensioning and tolerancing, 3D annotation, surface finishes, material specifications, etc., and it allows for manufacturing and inspection of the product without the need for your 2D drawings. Taking a look at our next topic here, NX PMI reuse within the company or other design processes here. The NX PMI is going to allow the digital data to be reused by parallel product development processes because that data is going to live with and is driven by that product's parts. So looking at the diagram here, we can see we have an automobile door. That information has PMI embedded on it, and that PMI can be reused with such things as variational analysis, work instruction sets, assembly process planning, part planning in NC manufacturing operations, as well as in your CMM inspection setups here. So a lot of value add here. Once you apply the PMI, you can reuse that PMI. This is going to utilize cost-effective and low-risk JT-enabled collaboration within the entire supply chain. It's going to leverage that PMI to create accurate, production-ready, and fully associative detailed drawings. And we can also create our PMI-driven machining operations, which is going to reduce your NC programming time by up to 20% here. We get into talking about the model-based enterprise here. So this is the reuse of that information, leveraging that information to help speed up other processes inside the design cycle here. The benefits of a model-centric solution here are that we can reuse this information across work instructions, analysis, assembly design, part design, tooling, requirements, manufacturing, suppliers, concept engineering, assembly and model documentation, as well as within the change process and generating different reports. This is going to reduce your cycle time by avoiding data transfer. Everything is embedded inside the digital master. Therefore, that digital file is king. So this is going to increase your innovation through the ability to rapidly explore more design variations more quickly. It's going to avoid redesign by validating manufacturing errors early on inside your development process. Also, the master model enables production changes without disruption here. Looking at the comprehensive digital twin, the comprehensive digital twin is encompassing these three core categories here: product design digital twin, production digital twin, and performance digital twin. Your product design digital twin consists of the CAD and the simulation. The production digital twin is the process, plant, and human operations here. And then the performance digital twin is the IIoT or the Industrial Internet of Things, essentially the reuse of this data being able to share that within the cloud and having somebody grab this information very quickly to use inside their design process or their part of the job. If we look at the model-based definition and the digital twin, if we look over on the far left, the drawing-based design process consists of only a drawing. This was the way that we traditionally created parts back before CAD design. We would create that part on a drawing or a drafting board, make modifications. This was all 2D, hand-drawn work. If a change came back to the designer, he had to go right back in, erase a line, add a line, etc. Here, a lot of work was needed here to modify that design. If we look at the model-centric design process, that includes the drawing and the model, and the drawing being driven based on the model geometry here. Once we started creating CAD parts, we were able to take that CAD geometry and bring that into a drafting environment, add some views to our drawing sheet, and manually go in and create the dimensions to the edges of the part in those views. Jumping over to the next image to the right of that, the model-based definition type design workflow, we will be applying the PMI to the physical geometry. The PMI is going to be related to the physical elements and reading the digital model and getting all the information from the digital model. What's nice about this is we can then take that to the next image over to the far right and use that digital information, that PMI, model-based definition, within our model-based enterprise here and complete our downstream model reuse by reading the PMI and reusing that model-based definition in all of our other operations. If something changes in that digital model, the PMI updates, the model-based definition information updates, and then all of our downstream operations will update according to those changes. Getting into our next topic here, PMI capabilities. All right, looking at the Siemens NX model-based definition portfolio, that does include the NX PMI and model-based definition, which will enable the production of a complete digital definition of your product within the 3D model, which is going to eliminate the need for your traditional drawings here. Next, we'll take a look at the different capabilities within the model-based definition application. That is going to be things like the PMI advisor, building rules, reuse of rules from a reuse library to quickly apply the PMI to your parts here. And then the PMI advisor is going to be utilized to check the PMI and the model-based definition against standards that you're using to design your parts to. So looking at the annotation tools within the PMI toolset here, if you think of applying PMI as being very similar to creating a drawing or a traditional drafting practice here, you're going to have all the same tool sets, so we can create dimensions, annotations, specialized objects, security markings, supplemental geometry. We can create searches and reports. We can do sectioning and create lightweight section views of our parts to go ahead and detail the internals of the part. And we can also take advantage of a mirroring functionality as well within the design environment. And finally, we can wavelength PMI and reuse that PMI inside of other part files. Now, when we get into talking about the standards for your 3D annotation, there are two standards here we'll be talking about: ASME Y14.41, 3D Digital Product Definition Standards, and then we also have the ISO 16792, Digital Product Definition Data Practices Standard. So the software is using one of these two standards based on how you design your parts. What standard you use, you're going to go ahead and set that in the settings. And then when you're building your PMI or adding your PMI to your parts, we can run the PMI advisor, and it's going to check against one of these two standards and look at the PMI, how it's applied to your parts, and give you direct feedback whether that PMI is falling within compliance with one of these two standards here. So we'll take a look at the dimensioning and annotation capabilities here. So this is a comprehensive dimensioning annotation capabilities that are going to allow you to fully define the geometry inside of your 3D environment here. It's fast and easy to create this PMI on your parts. The tool set is going to be very familiar here. If you've ever gone into the drafting application, you're going to have the same tool set here to apply the PMI on the 3D model. We can reuse features and sketch dimensions, so I can go ahead and have a sketch inside of that 3D part. I can right click and I can go ahead and convert the sketch dimensions to PMI very quickly if I need to do that. So reuse of the feature and sketch dimensions is also going to save you time creating PMI on your parts. We can utilize multi-CAD data with PMI embedded JT. So if we go ahead and embed the PMI, we can share a JT file and send that out to somebody, and they can use the JT to go viewer and see the embedded PMI on the part that way. These embedded PMIs, they are going to be standards compliant, of course, based on one of the two digital standards that is chosen there to design your parts to. And we can capture, display, and consume these PMI objects inside of a tabular format as well. If you look at the ribbon bar there on the image, you can see that the tool set is going to be identical to the drafting tool set as if you were in the drafting application. Instead, we're in a 3D environment, but we have the same tool set available, and it's very easy to add the PMI to the parts using these tools. Jumping into the next topic here, we'll be looking at supplemental geometry. So as defined by your 3D annotation standard, supplemental geometry supports your model-based definition drawing list initiatives here. We can apply our PMI center lines and center marks, such as full and partial bolt circle center lines. Dynamic and interactive controls are available with those tools as well. So as you're applying these bolt circle center lines, you'll see a series of handles. You can interact with those handles very easily. Click on the handle and make an adjustment to the size of the center line at that location on the center line. Additionally, we can prescribe PMI regions, and we can designate an area for special purposes, such as limited application of a tolerance, area affected by a datum target, or maybe a specific area on your part that you want to go ahead and show somebody that in this specific area, we don't want paint applied to this surface. So these are PMI regions we can specify in our design and write on our physical surface and tell or communicate to another user a specific area of this part needs this requirement, or this is an area to keep a certain finish off of this part. We also have lightweight sections we can create. So the PMI sectioning is very easy to do. Go over to a PMI view in your part navigator, right click on that view, and then choose the view and create a lightweight section of that particular view. There are multiple section type options. We can create automatic crosshatch definition from the material that's already been applied to the part here. And this is standard compliant, and it uses a standard compliant cutting plane symbol as well. If you look over in the far right image there at the top, we do have a cutting plane. You can see the actual the letters, the section cutting plane letters there with the arrows pointing to the cutting plane as we cut through this part. We can also mirror the PMI and model views as well here. We can reposition, delete, and we have some hide options. We also have the capability to wavelength PMI, and we can go ahead and reuse PMI downstream in other part files if we need to do that. Jumping into our demonstration here, we'll take a look at application of PMI on a part. All right, so here we have this part. We're going to jump into that part, and we're going to add a view set here. So the first thing we want to do is add a view set. We're going to give that a given name of PMI here. Once we apply our name, and we choose some views down below to add to our new PMI view set, these new view set views will be added to our part navigator, and you'll see that in the view set PMI there. In 1957, a new model-based definition navigator was introduced into the software. In this particular video, this is an older video, so we're using the part navigator. So the rapid dimensioning tool can be utilized here, and we can quickly apply some dimensions to our holes here. As you can see, it's reading the information about that physical hole, and we can apply tolerance to that just as easily as adding a dimension to a drawing here. In this case, we're using a 3D environment. Now we're going to apply a feature control frame. We can quickly add that to one of our hole callouts, and then add a datum feature symbol off of the feature control frame. Now, these three PMI elements have a direct relationship, and they go back to that hole. A section view can be created from one of your existing views. Right-click on the view, create lightweight section view. Go ahead and select that option there. And it's going to allow you to choose a cutting plane. We can specify the plane here to cut through that part, and then select OK. Now, once we cut through the part, we can easily apply some rapid definition or rapid PMI dimensions to the part. Picking these two edges here, we can apply this distance measurement, apply a tolerance, and now we can go ahead and associate some objects with that dimension. In this case, we're going to pick two faces to associate to this distance measurement. We're measuring between these two faces here. Once we pick the faces here, that's going to associate those faces with this PMI. We can easily place that now off to the right, and then begin creating our next dimension. And again, select associated objects here, the top and the bottom surface, and then apply that dimension and locate that inside our graphics environment here. Now we can apply some feature control frames. We'll apply a perpendicularity, add our tolerance to that. We'll go ahead and turn off our modifier here, and then we'll go ahead and apply that to the bottom edge of the part. We'll apply a datum here, representation, or representing datum C. Next, we'll export this part out in a JT file format. And you can see we can include the PMI with that JT file. Now, if we need to share these part files out with the vendor or customer, we can have them download the JT to go viewer, which is a free viewer provided by Siemens. They can open up the JT file format, and then they can go ahead and interact with that part very easily, and they can see all the embedded PMI on the part. As you can see, it's very interactive. If I click on that PMI note, it's going to highlight the surfaces associated to that PMI. And finally, we'll take a look at reuse of that PMI inside your drawings. So you can easily reuse the PMI and inherit that into your drawing views on your drawings. We'll add a PMI view here, the PMI top view in this case. Once we select that view, before placing that on our drawing, we'll right-click and go into the settings. Once we get into the settings dialog, we'll go into the PMI setting here and choose from model to inherit the model PMI into the view. Once we place that view on our drawing sheet, you can see the software does inherit the PMI information into the view from the model. Once again, we'll add another base view here. We'll go into our drop-down for a model view to use, and we'll choose our lightweight section view. After we place the lightweight section view, before we do that, we'll go into the settings again. We'll go into the PMI inherited category, and we'll inherit that from the model view. Placing that on the drawing sheet, you can see my view now has the inherited PMI in it. In addition to inheriting this PMI into your drawing views, we can also take advantage of the PMI and we can create technical data packages inside of our software. Once we export a technical data package, we can send out the views and all the embedded information with the model-based definition, including the PMI, can be included in that technical data package. As you can see in this demonstration here, we have a bracket technical data package that was created. Inside the technical data package, this is going to allow you to have this sent out to another user, send this out to a vendor, a supplier. You can send the technical data package out to them. They don't need an NX software installed on their computer. All they need is a PDF reader. Once the PDF document is opened up here, this technical data package includes all the information related to your part. Down below, you'll see all the parts that were chosen to be exported or added to the technical data package. I can cycle through all those views very easily here at the bottom and see the different information related to this part. Up above, we can go ahead and click inside the graphics window here, or this window. Once we do that, we can interact and rotate the view inside that display. Additionally, over on the right-hand side, we have some filters that have been built into our technical data package. We can filter by all, which is going to show all the PMI information down here in this list. Feature control frames, datum features, dimensions, and then important notes that have been applied to this technical data package. If I go back to the all category and choose the linear dimension here, it's going to navigate to the view and show me that linear dimension. We also have the capability to check the box here to zoom to the PMI. So if I check the box and I click on an additional dimension here, it zooms up to that dimension on the physical part, and I can zoom out a little bit and I can see exactly where that's at on the part. I can also additionally click on the PMI, and once I click on that inside the graphics display here or the window on the part, it's going to highlight that in the list over on the right. So this is called a technical data package, and you can export and create these technical data packages with all the embedded PMI information, as well as all the different PMI views embedded inside the technical data package. Okay, the next topic we'll look at here related to your model-based definition is the NX model-based definition capabilities. We'll take a look at the NX model-based definition, some key features related to that, automated PMI authoring, as well as the PMI advisor. Taking a look at some key features here, the model-based definition does allow for automated authoring of the PMI. We can capture key characteristics and knowledge about our parts, and the PMI advisor can be utilized for validation and guidance as you apply the PMI to your parts. There's also the capability to allow for direct consumption of your model-based data downstream in other operations. This is a patented technology. Siemens does hold multiple patents related to the automated PMI authoring here. It is an industry-first solution that delivers significant productivity gains for repeatable and predictable processes. There are rules that will allow for not only speeding up the authoring of the PMI, but these rules will also enable users to capture more intelligence inside the models. So for example, default tolerance, lookup tables, associative pattern counts, updates, etc. Now the rules are not going to be part specific here. They can be reused across multiple parts, and they can be reused over and over again. NX model-based definition does deliver 60 plus out-of-the-box rules that can be used for production, as well as to assist with learning how to author your own rules and add those to your library. The PMI Advisor is a fully integrated PMI validation solution that's going to provide notification verifying whether the PMI is in compliance with industry or company standards. This is going to ensure the production of higher quality parts in less amount of time here. It's going to provide guidance on corrective solutions, removing the dependency on your highly trained GD&T experts. And also notification options can include create, edit, and post-authoring workflows here as well. It is a flexible configurable checking modes that are allowed as well with this PMI advisor. You can tell the software that you would like it to advise you as you're placing the PMI on the part, or you can also configure that to enforce certain rules that will keep people from applying PMI to a feature on the part that it does not belong on based on the standards. This does support multi-CAD validation requirements as well. To activate the PMI advisor, all you have to do is go up to the ribbon bar on the PMI toolbar, and you can choose the advise option up there and open up the PMI advisor to run that process. So in this demonstration, we'll take a look at automated PMI authoring on your parts, and we'll take a look at the PMI advisor in action after the part has some PMI applied to it, and check the standard to what the part is being designed to, and flag the items that fall within the criteria for that standard. Maybe there's a warning related to the standard, or if that PMI falls outside the criteria of the standard, it will flag it with a big red X there and notify the user why something was flagged as incorrect. So we'll jump right into this demonstration here and get that going. So in this demonstration, we're going to be taking a look at this example part here, and we are going to be using some rules here to help to apply some PMI to this complex part. So we do have some capabilities with PMI to add the individual PMI using some of the tools up above here. But if we want to use some rules, we can go over to the right-hand side here on our PMI toolbar, and we can choose to insert an instance of one of the rules. Now with these rules, those are coming from a library, and Siemens does provide 60 plus out-of-the-box rules that we can use. We can also define our own rules, and we can use those existing rules to help us understand how to define new rules inside the software. Additionally, we can use frequently used PMI rules over and over again if we add those to the toolbar, and that will give us easy access to click on the icon and run that rule from the toolbar here. We're going to go into our reuse library. We're going to jump into our logical rules library here. And inside that logical rules library, you're going to see we have some different categories related to PMI. You can see automation, datums, dimensions, feature control frames, model views, notes, surface finishes, and technical data packages. We're going to enter the datum folder here. And inside that datum folder, we're going to use the datum across faces rule. Now you'll see down below in the member select, we do have a couple of other rules here. We have a total of 4 right now in this example. But the one rule we're going to use here is going to be create across faces. What create across faces is going to allow us to do is pick a single face And the software is going to look for the coplanar faces with that chosen face and apply the designated datum letter and datum identifier to all those faces at the same time here. We'll pick a face on the part. Once we choose that face, we can change the letter, or we can stick with the letter A that was already in here, and then we'll say OK for the rule to run. Once the rule runs on the part, you're going to see it's going to generate datum A inside the graphics display on that part. If we highlight datum A, you can see all of the faces that are all going to be coplanar in this condition, and those will all be representing datum A. If I had to go out and choose every one of those faces, it might have taken me 15 to 20 seconds, maybe if not more. Plus, I had to ensure that those were all on the same plane here. So as you can see, this rule is going out and doing all that work for me. And it's also going to eliminate errors. If I pick one of those incorrect faces and try and apply that to datum A, that's not on the coplanar condition, that is an error. Now, if we go back in and use synchronous technology here to move a face out of datum plane A, that face is no longer going to be coplanar with datum A. We can go right back into our model-based definition navigator. We can click on the create across faces rule here for the datum rule. As you can see, there's my datum feature symbol A. I can right click on that and I can update the rule. Once I update the rule, the software is going to go back through, interrogate the part, look for any changes that might have taken place inside that part, and reapply that rule appropriately to that part. Now, if we click on datum A, you can see the previously moved face is no longer part of coplanar group of faces, therefore it is no longer considered part of datum A. So next we're going to go in and apply an additional rule here to add some feature control frames. So we're going to apply another rule from the reuse library, a feature control frame rule that is going to add some positional tolerance on some features here. We can customize the settings from the feature control frame inside the dialog box here. We can modify our tolerance. We can remove our material modifier here. And then we can go ahead and specify the datum related to the feature control frame. Once we select OK, the software is going to go out, run the rule on the part, and it's going to create all the position tolerances on the part. Once the rule is completed, NX is using feature recognition to locate the size of the holes and then group them individually and define patterns for the holes as well. As you can see with this instance, we have 6x indicator before the feature control frame, and the software recognized there were 6 of the same types of holes on this part, and therefore it just puts the 6x in front of the feature control frame here. Now you can see with that rule, we can always go right back in and we can modify our tolerance value and change that from 0.15, maybe to 0.2 here. Once we hit enter, all of the feature control frames will update accordingly here with the new variable. Now we'll go ahead and take a look at the PMI advisor. Once you've applied your PMI on your part, we can use the PMI advisor to help validate the PMI that was created on that part. So we're going to go into the menu PMI and go down to the advisor category here. We're also going to go into the configuration dialog box here first. So we're going to take a look at some settings, take a look at what that configuration dialog box looks like. You can see this is the main dialog for managing the types of rules that get applied for your PMI. With the checking mode, we can tell the software to advise us, or we can tell the software to enforce, which will also show the errors and prevent you from adding PMI that falls outside of compliance with the standards that are set. Down below that, you'll see the active standard right now is set to ISO. So it's using the ISO digital standard when it's checking your PMI on your parts. Depending on what standard you want to use, you can hit the drop down and you can choose either ASME or the ISO standard here. We'll stick with the ISO standard. Over in the middle section here, the rules customization section is where we're checking rules. Our checking rules can be turned on or off, as well as some different preference settings turned on per rule. As you can see, we have all of our different categories here. In this case, feature control frames. Over on the right-hand side, this is the rule setup, and we can tell the software what the failure level is going to be here. We can also toggle to apply the rule or toggle off to not apply the rule. With the failure level here set to error, the software is going to give the user an error if that PMI, in this case the feature control frame, has no associated geometry. You can see that's going to flag that as an error. We also have a warning setting or an informational setting here. So we'll go ahead and exit the configuration dialog and jump into creating a datum feature symbol on our part. If we use the letter I here while applying the PMI advisor does show up and it flags this with some alerts. It says the datum letter sequence contains an invalid character, and down below it's telling you why. So a datum label must contain at least one alphabetic uppercase letter. The letters I, O, Q are not acceptable here. So we'll go ahead and place datum I on the part, and then we'll run the advise check on the model. Once we go up to the toolbar here, we can select the advise button to open up the PMI advisor. Now the PMI advisor is part of the HD3D tools package here. We're going to go ahead and run the advisor check. Once we run that on the part, you can immediately see we have some indicators showing up next to each one of those PMI elements. The items that have a warning will be the yellow triangle with the exclamation point. Anything that passes, of course, has the green check mark. And then anything that fails will have the red X. If you put your cursor over those indicators on the graphics display next to the PMI, it's going to tell you what the warning means, why something failed, and why something passes. So you can see you can interact with those different indicators and get additional information if you need to do that. So we're going to go ahead and edit this datum, and we're going to change our letter to B here, and then go ahead and close that out. We'll rerun the advisor. Once we run that advisor check one more time, you're going to see that my datum now passes based on the standards criteria. To fix the warnings on our position controls with maximum material conditions in the frames, we can go into the rule and we can remove the maximum material condition modifier from those frames. We'll go right back over to our model-based definition navigator, click on create position from datum, go down to the details section, and in our material modifier here, we can go ahead and remove the MMC condition off of the feature control frames. Of course, those will update across the entire part. We can go right back in and we can run our advisor check one more time, and this time the PMI will pass. So as you can see, the benefits of the PMI authoring rules in conjunction with the PMI advisor, it's going to save you a lot of time, eliminate errors, and if it's a user that's not as familiar with the GD&T when that's applied to the parts, the nice thing about the advisor is going to check the part thoroughly to make sure that the PMI that's being applied to those features is going to pass within the standard. If something fails, a user can select on that. They can see why something failed and get information to learn more techniques with GD&T and how that's applied correctly under the standards here. All right, our next topic here is going to be downstream uses for your PMI. We'll take a look at downstream use of NX model-based definition within the tooling, design, and analysis functionalities, machining, part planning, and NC manufacturing, as well as in inspection here. So with our downstream uses of the NX model-based definition, we can reuse PMI in both downstream and parallel product development processes. The nice thing about this is that we can reuse the data. All we have to do is apply it once on the physical model, and that information can be reused over and over again inside different operations with other colleagues' parts or their part of the design process. The items we're going to focus on here are analysis, inspection, and manufacturing. With a VSA setup here, we can simulate manufacturing and assembly processes and predict the amounts and the causes of variation in our designs. Variation analysis reduces analysis time by up to 50% and improves your accuracy with your designs. In our mold concept design, 2D PMI symbols can be used to represent 3D standard parts inside the mold assembly with automatic placements. We can utilize feature and tolerance definition directly from the PMI. Looking at machining, part planning, and NC manufacturing, PMI-driven machining, we can take advantage of the PMI, and with NX CAM, we can automate toolpath creation and tool selections from model-based definition on our parts. We can select the correct machining process and tools depending on the machining feature, and this will reduce NC programming time by up to 20% here. It does support the reuse of PMI inside parallel product development processes by leveraging your manufacturing knowledge within the machining process. And finally, with the inspection processes here, we can utilize the PMI for our PMI-driven inspection operations. NX automates inspection programming based on the PMI and model-based definition. We can leverage that PMI to automatically create our inspection features, inspection tolerances, and inspection probe paths on our parts. The inspection method and feature types define the inspection path, and this is going to reduce your inspection programming time by up to 80% on these parts. This will ensure the CMM programmer can capture the design features and the tolerances directly from the model without re-entry from a drawing. And to wrap up the presentation, we'll look at a quick summary of all these model-based definition and PMI capabilities. So this process is going to save time, enhances and shortens the design and decision cycles by delivering documentation electronically instead of a physical hard copy print. It's also going to save cost here. It's going to reduce your cost in drawing preparation time by using the PMI-based models. Your quality is going to increase. It's going to reduce scrap and rework by analyzing, optimizing, and validating your products virtually before actually cutting metal, as well as increasing quality by optimizing the change management process. Lessons learned for a successful deployment of a model-based definition strategy. The first thing you want to do is adopt a strategy here. So we want to develop a roadmap that aligns with our business goals. Every business is different. Therefore, you want to look at your company and how is model-based definition and PMI going to help my design process at my company. When producing an implementation plan here, you want to include all the departments who could potentially leverage the model-based definition data. You want to plan and budget for education on working practices and technology for the authors as well as the consumers of the model-based definition. For the process evolution, you first want to establish the model as the source of truth. That physical model is going to have all the embedded information on it. The physical model is king here. And as you embed that information on the model, you can reuse that downstream and in the other processes. And now all the information is coming from the physical model and not from a drawing. You want to develop working practices for both your authors and your consumers of the model-based definition data. You also want to consider how data is going to flow between the different process steps here. Develop your online and offline collaboration processes amongst the different design groups. For your risk management section here, for the risk management portion here, don't underestimate cultural impact. Ensure benefits are clearly conveyed to the team. Run pilots with well-understood use cases, so start out with one single part, one project, and work from there. Once you develop and track the productivity with that one project, take a look at your return on investment, and then you can go ahead and share that with the rest of the other design groups and start to roll this out to other projects. And you also want to anticipate investment inside the supplier adoption. Once you start to use model-based definition on your parts and your designs, you do want to share this process with your vendors, your suppliers, and teach them about model-based definition and how it applies to your designed parts here. All right, thank you very much for watching. Once again, here's my contact information. And coming up next, we'll be looking at NX CAM post-configuration presented by my colleague, John Vincent.